Hello there, and welcome to Chapter 6 or Lecture number 6, Language of Chemistry. So, we will again use here the book of Charles Corwin, Introductory Chemistry Concepts and Critical Thinking, 7th edition. So, shown here in this slide is the topic outline. So, we have a discussion on classification of compounds, monoatomic ions, polyatomic ions, writing of chemical formulas, binary ionic compounds, ternary ionic compounds, the Latin system of nomenclature, binary molecular compounds, binary acids, and ternary oxyacids. So we will be covering all of these topics at the end of the chapter. So to start, there is an organization called IUPAC, and that stands for the International Union of Pure and Applied Chemistry. So IUPAC as an organization, they set the rules for naming compounds. So just a quick fan fact about IUPAC, it is organized or established in 1919. So since then, IUPAC set the rules for naming and classification of inorganic compounds in 1940. So these rules, referred to as the IUPAC nomenclature, are still used in today. So this is the logo of the IUPAC. So for the discussion of our classification of compounds, so most inorganic compounds do not contain the element carbon. So there is a division. So we have two sub-branches of chemistry, organic chemistry, and the other one is inorganic chemistry. So inorganic chemistry uh, studies inorganic compounds. So when say inorganic compounds, these do not contain an element carbon. However, there are exemptions. So ang exemptions natin dito is your carbon dioxide with a chemical formula of CO2 and carbonates, which is an ion, and the formula is CO3 2 minus. So why is it carbon dioxide and this carbonate is an exemption? Kasi if we will look into the definition of organic compound, this is a compound with carbon that is usually bonded to a hydrogen. As you can see in the formula of carbon dioxide and carbonate, you don't have here hydrogen. So, carbon dioxide is also considered as an inorganic compound, as well as your carbonate. So, allow me to present here the classification of inorganic compounds. So, we have five common classes. So, it could be a binary ionic, a ternary ionic, a binary molecular, a binary acid, or a ternary oxyacid. So, in this slide, nakikita nyo dito, this is just a flow chart. So, para mas mabilis siyang makita or visually, mas ma-appreciate ninyo yung classification natin. So, your inorganic compounds and acid will be divided into three: ionic compounds, molecular compounds, or aqueous acid. Under ionic, you have binary ionic compound and ternary ionic compound. For molecular, you have here just a specific name niya is binary molecular compound, and for aqueous acid, you have either binary acid o a ternary oxyacid. So later on kasi magkakaroon tayo ng ano may ibig sabihin yung terms na binary and ternary. Okay? But before we dwell into that, let's compare muna yung ating ionic and covalent. So when you say an ionic bond or an ionic compound is formed, so it is formed between a metal and a non-metal element. So please take note of this description. A metal and a non-metal. If you want to use another definition, so ang description naman niya is the transfer of electrons. So which one will give its electron and which one will accept? So your metal here will be the one to give electrons. and then the non-metal element will be the one to accept. So if you're giving an electron, then someone should accept it. So there is may involvement dito ng transfer of electrons. On the other hand, your covalent bond or covalent compound, this is formed between two nonmetal elements. So, as I mentioned earlier, yung mga nonmetals natin, ang mas gusto nila is they accept electrons. However, if you have two nonmetal elements, sino wala sa kanila yung pwedeng magbigay o mag-give off ng electron. So they both want to accept. So instead of one giving off and the other one is accepting, so they just share their electrons. As exemplified here in our example, two chlorine atoms. So your chlorine atom wants to gain another electron, and this chlorine atom also wants to gain another electron. So instead of uh losing and the other one is just accepting the electron, they just share their electrons. So upon sharing their electrons, then a bond is formed. So that's why in nature Cl or chlorine is found as a diatomic ion. So when say diatomic molecule means na you have two atoms bonded together. Okay? So that is a covalent and ionic bond, a difference between the two. So it is important that you know the classification of element based on the position in the periodic table. So I mentioned this in the previous lectures that in your periodic table you have here a zigzag. So in the zigzag, everything to the left is your metals, so shaded in violet. To the right of that zigzag is your nonmetals, shaded in yellow. And there are elements along the zigzag. These are your metalloids or semi-metals. They are color-coded as green. So you should know the classification of element based on its position in the periodic table. Okay, now let's go into the difference between the ionic compound, the molecular compound, and the acids. So, in the previous slides natin, we have two subdivisions pa under ionic compound. We have binary ionic and a ternary ionic. So, what's the difference? In a binary ionic compound, this contains two elements. So, one is a metal and the other one is a non-metal. An example natin ito is your NaCl. So, Na is your sodium that is metal, and then Cl is your non-metal. So, this is an example or picture of NaCl or salt. In a ternary ionic compound naman, on the other hand, this contains, from the word itself, ternary, we have three elements. So again, dahil ito ay ionic compound, then there should be at least one metal and one non-metal element. Okay? And the third element should be a non-metal. So for example, you have KNO3 or potassium nitrate. So K here is a metal, N and oxygen, nitrogen and oxygen, these are both non-metals. So as you can see in the formula KNO3, you have three elements. One is a metal, two are non-metals. For molecular compounds, we have a mas specific na pangalan niya is yung binary molecular compound. So this contains two elements and both are non-metal. If you will recall our discussion in chapter 3, a molecule is defined as a unit of matter composed of two or more nonmetal atoms. So, for example, ang ating mga binary molecular compounds here are your ammonia, NH3, and water, H2O. And in the picture, this is P4S3. So, as you can see, in ammonia, we have nitrogen and hydrogen. So, just two elements bonded together. In water, you have hydrogen, and the other one is oxygen. In this picture, P4S3, we will not give the name muna. So P4S3 is a compound that is found in self-striking matches. So dati kasi uso yung um, match na you just strike in any surface and then it will ignite. So it contains P4S3. And dun sa ating last na classification is yung aqueous acid. So acids. So since we have here a term aqueous, which is a new terminology, let's define it. So aqueous means it contains water, or it is a substance is dissolved in something, in a solvent, which is usually water. So we have um, below aqueous acid, we have two subclassification. We have binary acid, and the other one is a ternary oxy acid. So what's the difference? So in a binary acid is an aqueous solution of a compound containing hydrogen and another non-metal. So binary means you have two elements, non-metal. In a ternary oxy acid, so this is an aqueous solution of a compound containing hydrogen, oxygen, and another non-metal element. So in a ternary, you have three non-metal element. And the composition ng tatlong non-metals natin doon is one hydrogen, one is oxygen, and the other one is another random non-metal. So for example, for binary acid, we have HCl. This is this is a binary acid. So H and just a chlorine atom bonded together. So this is HCl. On the other hand, you have HNO3. So you have hydrogen, nitrogen, and oxygen. So HNO3 is a ternary oxy acid. So may term dito na oxy acid. Why is it oxy acid? Acid kasi you have the presence of H, and oxy referring to oxygen. So sa acids kasi, um, there is a definition of acid kasi na there should be an H or H plus. It gives off H plus. So HNO3 is an example of a ternary oxy acid. Now let's go to ions. And we can also classify ions. But before that, let's recall that an ion is an atom. So when saying atom, it's single, or a group of atoms with a charge. So what is the possible charge natin dito? This is either positive or negative. So a positively charged ion is called a cation, while on the other hand, a negatively charged ion is called an ion. And if there are groups of atoms bonded together, and it also has an overall charge, then we call that a polyatomic anion or cation. So when say polyatomic anion, this is negatively charged. A polyatomic cation, meaning an overall charge niya is positive. So again, I'm representing here or showing here a flow chart for clarity. So your ions could either be a cation or an ion. Let's say cation, positively charged, anions are negatively charged. Under cations and anions, you can see here a similarity in the two ions natin. We have monoatomic and the other one is polyatomic. And say monoatomic, this is single or just one. For polyatomic, you have two or more. So two or more what? Elements. So if two or more elements are bonded together but overall they have a charge, so we call that polyatomic cation or polyatomic anion. So for monoatomic, ano muna tayo na example. So paano ba nagkakaroon ng monoatomic ion? So it's either your neutral atom loses an electron or gains an electron or electrons. Upon losing electrons, it will become positively charged or a cation. On the other hand, if your element gained or accepted electrons, it will become negatively charged. Bakit? Electrons are negatively charged. Diba? Na-discuss natin yan in subatomic particles. So, the more electrons you add to your atom, then the more negative it becomes. So, that is called an ion. A negatively charged ion is called an ion, and a positively charged ion is called a cation. So, paano ba nagkakaroon ng monoatomic ion? So, we'll look into muna the positively charged cations. So, metal atoms can lose valence electrons and become positively charged ions, or positively charged ions are called cations. So here is a diagram for sodium. So we know that sodium has 11 atoms. So in the outermost shell ng ating sodium, there is an electron. So this electron, pwede yang mawala or malose. So if this electron is lost, nawala yan, or maybe it was transferred to another element, then what happens to the charge? So your sodium becomes positive. Okay? So how do we name your cations? So cations are named for the parent atom followed by the word ion. For example, Na+, so that is called sodium ion. For Mg2+, this is called magnesium ion. So this rule applies for metals that usually form just one ion. So this includes the main group elements or main group metals except for tin and lead, along with Ag plus, Zinc 2 plus, and Cd2 plus. So ito pwede mo namang basahin na kahit hindi na Ag plus or silver ion. This is Zinc 2 plus, pwede mo rin siyang basahin na zinc ion. Or kaya naman Cd2 plus is your cadmium ion. So, bakit hindi kasama yung tin and lead? So, tin, symbol niya is Sn, and lead is Pb. So, meron kasing possibility na hindi lang isang charge yung ma-create na cation. So, meron dito nakalagay na main group metals. So, if you will recall your periodic table, ito yung parang appearance niya. So, to the left and to the right, these are your main group elements. So, since metals lang yung naglulose ng electrons, and then we have here the zigzag. So, nakaka-form sila ng cations, yung mga metals natin dito. Okay? So, paano ini-name yung ating mga cations na may more than one cation? So, it is named using the parent, so the name of the element followed by the charge. And usually, ito ay sinusulat in Roman numerals. And the Roman numerals are enclosed in a parenthesis, followed by the word ion. For example, copper can exist as copper plus and copper 2 plus. So, yung copper plus dito, it means the charge here is just 1. So, kapag nakita niyo yung positive plus sign lang siya, it means 1. So, copper plus is copper ion. So, copper I or copper 1 ion. Copper 2 plus is copper 2 ion. So, you write the you write the number in Roman numeral. So 1 or 2. Then you just add the word ion. So this process of naming is called the stock system. So this is called the stock system of naming transition metal cation. So nasan ba yung mga transition metals natin? Again, if we will draw the periodic table rough na drawing. So again, these are your main group. In the middle, this is your transition metal. So bakit? Kasi yung mga transition metals natin, they can exist more than one cations natin. So that's why kailangan natin siyang bigyan ng proper designation kung siya ba ay copper 1, copper 2, and etc. Kasi nag-iiba-iba yung charges dun sa mga transition metals natin. There's also another way of naming. This is called the Latin or the suffix system. So again, this is applicable for metal ions with two more cations. So medyo kakaiba yung naming niya kasi this system takes the Latin name of the element and you add the suffix us or ik. So dito dapat alam niyo yung Latin name. So paano ba ina-assign yung us and ik? Yung cation with the lower charge receives the us suffix, while the cation with the higher charge receives the ik suffix. For example, again, let's use copper, and we know that copper can exist as copper plus or copper 2 plus. So since copper plus is lower in terms of charge, we will look for the Latin name. So yung copper kasi is cuprum. So cuprum siya. Then, we will use the us for the lower charge. So, copper plus is called cuprous ion. Take note of the us. And then, yung ating copper 2 plus is given a suffix ik. So, it became cupric ion. So, dun sa ating mga transition metal elements, pwede din siyang gamitin. Okay? The Latin system is less common than the stock system. So, mas preferred na ginagamit yung stock system. So, mas madali siya kasi in the Latin system, you need the Latin name and then you add the os or the ik. So, medyo nakakalito siya if you use the Latin or the suffix system. But in stock system kasi, it's straightforward. Copper plus is copper 1. Copper 2 plus is copper 2 ion. Okay? On the other hand, if your metals lose your electrons, ito namang non-metals natin, they gain electrons. So, when they gain electrons, they become negatively charged ions, or we call this as your anions. An example here is oxygen. So, oxygen has 8 electrons. 8 electrons. So, oxygen has this tendency to gain electrons. So, at most niya, it will gain 2 electrons. So, as you can see here, from 8, it became 10. So, and alam niyo na naman, di ba, that electrons are negatively charged. So, if you add more electrons to your structure, then the more negative your charge becomes. So, from oxygen, it will become O2 minus. So, O2 is named as oxide. So there's also a way to name your anions. So monoatomic ions are named by dropping the end of the element name and adding the suffix "ide". So for example, in table 6.2, this shows the common monoatomic anions natin. So we have Br minus, Cl minus, F minus, I minus, N3 minus, O2 minus, Fp3 minus, and S2 minus. These Br, Cl, F, and I, these are your halogens. If you could still remember our discussion of the different groups. So usually they end in the ine. For example, bromine. So in the rule, we will remove the ine and we will just affix the ide. So from bromine, bromide. Chlorine, chloride. Fluorine, fluoride. And then iodine is iodide. For other non-metal elements natin, we also use the IDE. So for nitrogen, it becomes nitride. For O2 minus, it becomes oxide. P3 minus is phosphide ion, and then S2 minus is called the sulfide ion. So as you can see, they all end in the ide suffix. So is there a way to predict the ions for a particular element? The answer is yes. So how? Recall your discussion of groups and families of elements. So we know that we have 18 groups. So that is numbered 1 to 18 based on IUPAC. But if you want to use the A, B, you have the A elements to the left and to the right of the periodic table, and the B elements here are situated in the middle. Okay? But according to our discussion last time, we have 8 well-known families. So based on their position, based on the position of the columns or the groups, we can assign the charge of your element. So for group 1A or group 1, these are metals or alkali metal. They always form the 1 plus or the plus 1 ions. For group 2A or group 2, they always form the 2 plus ions. So this is your alkali earth metals. You can also predict that group 3A or 13 ions form 3 plus. Your 4A or 14, group 14, um, though we know that it can form plus 4 or 4 plus, not all metal ions are predictable. So yung ating tin and lead kasi, it can form the 2 plus and the 4 plus ion. So remember in my discussion kanina that SN and PB, there are the exemptions. So they can form 2 plus and 4 plus ions, even though they belong to the group 4A or the 4T. And then for transition metals, the elements that are found in the middle of your periodic table, most transition metals form 2 plus ions from the loss of their 2 electrons, 2s electrons. So on the other hand naman, nonmetals, so nonmetal elements gain electron. So to form an ion in a predictable fashion. So we can also predict the the charge of your anion based on the position on the periodic table. So for group 5A or 15, so atoms in that column will gain 3 electrons and form the 3 minus ions such as N3 minus and the P3 minus. So this is your nitride and this is your phosphide. For group 6A or 16, so atoms in that column, they can form 2 minus ions by gaining 2 electrons. So this is your O2 minus oxide, S2 minus sulfide, and Se2 minus, this is called your selenide. And lastly, for group 7A or 17, so these are your halogens. So they gain 1 electron to form the 1 minus ion. So this comprises your F minus or fluoride, chloride, bromide, and your iodide ions. Yung ating last na column, which is noble gases, they don't form ions. So they don't want to mingle with other elements. So here is a visual representation of what I have said. Based on the position, you can predict the charge of your element, your cations and your anions. So as you can see here, in the middle part, the transition metal elements, they can form more than, actually more than two cations. So example, Fe, you have 2 plus, 3 plus, cobalt 2 plus, 3 plus, copper, copper plus, or copper 2 plus. So that is how you can predict the charge of the element, well, based on its position in the periodic table. Allow me to to discuss this H, because H, though it's not that is not a metal element, it can form an H plus. So if you remember, say P and E of your hydrogen is just one. So there is one proton and then one electron for hydrogen. So this electron can be uh, transferred or could be lost. So what happens? It becomes H plus. Okay. So this is a quick representation of the different charges of the different elements. But hindi naman hindi lang naman yung charges na napo-form ng ating mga elements. So allow me to share this with you. So this is a periodic table of common ionic charges. So some elements will not form ions. So some can form two, two ions. Two cations actually. For example, iron, manganese, chromium, vanadium, titanium, nickel, copper, palladium, and so on. So you don't need to copy this one or memorize this one. Okay? So that is a discussion for monoatomic ions. So how about if you have polyatomic ions? So when say polyatomic, you have two or more elements bonded together, but overall they have a charge. It's either positive or negative. So polyatomic anions generally contain one or more elements combined with oxygen. So if this is the case, then that polyatomic anion is called an oxy anion. So from the name itself, oxy, you have oxygen, an ion, you have a negative charge. So most oxyanions have names that end in the suffix "ate." When say suffix, this is found in the end of the name. So it usually ends with "ate." For example, NO3 minus is called nitrate. SO42 minus is called sulfate. So aside from oxyanions ending in "ate," so there are also oxyanions that end in the suffix "ite." So what's the difference between the "ite" and the "ate"? So in example natin ng mga "ite" oxyanions is this one. NO2 minus is nitrite. SO32 minus is called the sulfite. So the difference between the "ate" and the "ites" dito is just the number of the oxygen. In our "ites," "ite" ions, you have one less oxygen. From example, originally nitrate is NO3. So you have three oxygen dito, but in nitrite you have just two. In sulfate you have four, then in sulfite you have just three. So oxyanions that end in "ite" have one less oxygen than the oxyanions that end in "ate." So just a difference of one oxygen. Okay? So for example, ito, the formula for chlorate ion is ClO3 minus. What is the formula for chlorite ion? So as you can see, the suffix has changed. So from A to I. So chlorite must have one less oxygen than chlorate. So the formula is ClO3 for chlorate. You just deduct 1. So the formula is ClO2 minus. Take note here that the charge does not change. So even though you change the number of oxygen atoms, the charge does not. So the charge does not change even though you change the number of oxygen. So I mentioned earlier that there are polyatomic and polyatomic anions or oxyanions that end in ate and ite. But there are exemptions. So there are two common polyatomic ions that end in ide naman. So we have your hydroxide and the other one is your cyanide. So hydroxide is OH minus and cyanide is CN minus. Okay. So allow me to share with you here table 6.3, a list of the common polyatomic ions. So we can divide the table into two. We have your cation and your anion. So for cation, we have one cation here called the NH4 plus. So this is called the ammonium ion. Then we have your anion. We have acetate, carbonate, chloride, chlorate, chromate, cyanide, dichromate, and so on. So, again, the rule is the general ending kasi ng ating mga polyatomic ions ay 8 and 8. But there are again exemptions like your cyanide and your hydroxide ion. Okay? So, we will use this uh, table for naming or writing the chemical formula. So again, let's recall in chapter 3 the definition of a chemical formula. It's an expression of the number of atoms of each element in a compound. Example, you have sulfuric acid. The chemical formula is H2SO4. So we have two atoms of hydrogen based on the chemical formula. You have one atom of sulfur and then four atoms of oxygen. So we will discuss here the different rules that should be observed when writing chemical formulas, starting with your ionic compound. So again, we know that ionic compounds are composed of the positive and the negative ions, or your cations and your anions. So when you write your chemical formula, so a formula unit is the simplest representative particle of an ionic compound. So a formula unit should be neutral and always neutral. So when say neutral, the charge is zero. Overall, the charge is zero. For this is for the compound. So if we will look into the positive charge and the negative charge, then the total positive charge must be equal to the total negative charge of the in the formula unit. So why? If your positive charge is equal to the negative charge, if we will add the two, the overall value will be zero. So for example, in your formula unit, you have plus 2 or 2 plus, then the negative charge should also have the same number. So 2 plus, the other one will become 2 minus. So if you add the 2, the charge is 0. So for example, if the ions in the ionic compound have the same charge, the formula unit contains one of each ion. For example, K plus and Br minus. So you have your potassium ion and your bromine ion or the bromine. So if these two will combine together, this will form your KBr. For another example, you have calcium 2 plus and O2 minus. So you have the same charge. So you have the same charge, but just the difference is a positive, is a negative. So these could combine to form your KAO. Okay? CaO rather, CaO. However, if the charges are not equal, then we must balance the positive and the negative charges. For example, you have Ba2 plus and the other one is Cl minus. So if you will combine the two, it will form BaCl2. On the other hand, if you have Li plus and the S2 minus, this will combine to form your Li2S. So the question now is, how did that happen? So I can share with you the technique which is called the crisscross method. So in crisscross method, you just exchange the number. So the rule there is, for example, in aluminum and then you have your oxygen, we know that aluminum has a charge of 3 plus. Oxygen always have a 2 minus charge. So what will happen here is the 2 will become the charge 2 here in the oxygen, the 2 will become the subscript for aluminum. And the 3 here will become the subscript of your oxygen. When we say subscript, this is the number that is written below or smaller or yeah below. For example, Al2O3. So the 2 and the 3 here, these are your subscripts. So as I mentioned earlier, your the charge on the aluminum ion becomes the subscript of oxygen. So 3 will be transferred to oxygen, so it becomes O3. And the charge on the oxide ion, the 2 here, becomes the subscript for the aluminum. So that's why we come up with Al2O3. So you can use the crisscross method if the charges are not the same. For example, Ba2 plus and then Cl minus. So you transfer the 2 to the Cl and then Cl. If you notice there is a minus sign here, so that means it's just 1. If there is no number here, then automatically that is just 1. So 1 here transfer to Ba. So that the charge of your barium will become the subscript for Cl. So that's why it became BaCl2. For Li plus and then S2 minus, you transfer the 2 to the Li and then transfer 1 to the S. So it became Li2S. How about if we have now the possibility of a polyatomic ion? So when say polyatomic, you have an ion or a cation that has two or more elements, but it is either positively charged or negatively charged. Example, Mg2 plus and the other one is SO4 2 minus. So again, in the rule, you don't need to use the crisscross method. So you just, if you have similar charges, you just copy each. So it became here MgSO4. On the other hand, if you have your polyatomic cation and the polyatomic anion, so and the charges are not equal, then the total charge must be equal to 0. So you can also do here your crisscross method. So for example, NH4 plus and then SO4 2 minus, this will combine to form NH4 2 SO4. Why? We will transfer the 2 to the NH4. So since you have here a polyatomic cation, should enclose it with the parenthesis. So NH4 2 and then SO4. That's why we arrive here at this formula. NH4 2 SO4. So just to insert this, um, we know that potassium is an extremely reactive element and it's very reactive with water. So as shown in this picture, there is the production of flame, production of sparks. But come to think of it, how can such a reactive element like potassium, when it reacts with water, how could it be essential for human life? So potassium ion or the K plus is essential but not the free element. Why? Because as we have mentioned earlier, K or the potassium metal itself is reactive with water. We are made up of around 70% water. So if we will ingest potassium, then it will react with the water inside our body. But if it's in the form of K plus or ion, then it is now beneficial or essential. So we have good sources of potassium, and this includes your fruits, your especially banana. You have your green vegetables, protein sources, whole grains, and dairy products. So I just want to insert this topic about uh, the difference between an element in an ionic in its ionic form and an element in its natural form. So we can utilize the element if it's in the if it's in a an it in its ion form but not in the free element. So now how about if we will name binary ionic compounds? So when say binary, you have two elements, one is metal and the other one is a non-metal. So if an ionic compound contains a metal that can have more than one ionic charge, then we must determine the charge on that ion. And the sum total charge of an ionic compound must be equal to zero. Ang ibig sabihin lang nito, the charge should be zero. Okay? Kasi if your compound will have either positive or negative, then that becomes a cation or an ion. So, for example, there's a question here. What is the charge of the chromium ion in the Cr3 and 2? So, this is how we can solve it. So, the charge of the nitride ion is always 3 minus. So, when say nitride, this is N. So, N3 minus. So, the charge is 3 minus. And since we have two nitrogens here, we will multiply 2 by the 3 minus. So the overall negative charge is 6 negative. I mentioned earlier that the charge should be equal. So ang ano lang dito, difference sila is one is positive and the other one is negative. So if you have 6 negative, then the other ion should be 6 positive. But since in as you can see in the formula, you have 3 chromium, then we need to divide the 6 positive into 3. So to get the charge of a single chromium atom. So 6 or plus 6 divided by 3, then each chromium has a charge of plus 2, or the proper way kasi talaga of writing is you write the number first then the symbol. It's either positive or negative. So each chromium has a charge of 2 plus. But there's also another way to solve this. So this time naman, gagamit naman tayo ng algebra. So we know that the compound should be 0. Okay? Then, in algebra, we will use variables. So for example, let's assume x as the charge of your chromium. Okay? And then we will set up the equation. So since in the formula, the chemical formula, you have 3 chromium, then you have 3x. Then you add the charge for the N. We know that N or nitrogen can form a N3 minus. So we have minus 3. And since you have two atoms of nitrogen in the chemical formula, we will multiply negative 3 by 2. And the overall charge should be 0. So let's simplify first. So 3x. So negative 3 times 2, this is plus minus 6. This is equal to 0. So 3x plus minus 6 is equal to 0. Let's transfer the negative 6 to the other side of the equation. It becomes positive. So plus 6. So 3x is equal to plus 6. Let's divide both sides by 3 to get the value of x. So x is plus 6 over 3. You have plus 2. So the charge of each chromium is 2 plus. So again, I'm using here the convention. We'll start with the number, then followed by the plus sign or the negative sign. So when naming ionic compounds, we combine the cation and the anion. So we drop the word ion. And we will write the cation first. So the cation, the one with the positive charge, and the anion will be second. For example, MgO, this is composed of one magnesium and one oxygen. So we call the magnesium as the magnesium ion and the O as the oxide. So since we will drop the terms ion, yan, so this will become magnesium oxide. So the name for MgO is magnesium oxide. So let's give another example. What is the name of cinnabar or with the chemical formula HGS? So again, we can use here algebra. So let's say X is the charge of your mercury. We know that sulfur has a charge of minus 2. So let's set up the equation. We don't know the charge of Hg, the mercury. Then we add the charge for sulfur. And since this is just 1, so the value here is minus 2. And that is equal to 0. So H plus minus 2 equal to 0. X is equal to, this becomes positive if you transfer it to the other side. So plus 2. So the charge of Hg is plus 2. So it doesn't stop there kasi we need the name. Since you know the the information that Hg has a 2 plus charge, then this is named as Hg2 plus is the mercury 2 ion. And the S2 minus is called the sulfide ion. So the name is mercury 2 sulfide. So mercury 2 sulfide. Okay. So now how do we predict the formula for binary ionic compounds? So for example, what is the formula for iron 3 fluoride? So ano yung mga information na meron tayo dito? So we know the name of the metal, which is iron. So iron here has a plus 3. That's why the the convention will be Fe3 plus. Then you have here fluoride. So fluoride is fluorine. And the usual charge of fluorine is minus 1 or F minus. So yun yung mga details na meron kayo. And then you can use the crisscross method here. So Fe3 plus, and then you have F minus, crisscross. Then your Fe will will have the charge of your F. So since this is just one, so you don't need to no need to write one. It's understood. Then in for fluorine, it will receive the charge from Fe. So it will become 3. So the formula or the chemical formula for iron 3 fluoride is FeF3. Okay? Since the total charge must be equal to 0, the formula for iron 3 fluoride is FeF3. So again, the charge for F is negative 1. And since you have 3, this becomes negative 3. Then for Fe, the charge is plus 3. So if you will add plus 3 and minus 3, the charge is overall 0. So dapat 0 lagi yung charge ng inyong compound. Now, how about if you have 3 or more elements? So, in a ternary ionic compound, we have 3 elements. There should be at least one metal and the other one is a non-metal. So, similar way of naming with your binary ionic compounds. You usually start with the cation followed by the anion. For example, KClO2 is named as potassium chloride. So, K here is potassium. Then chloride is ClO2 minus. If we have a metal that can have one oxidation state or one or more charge, then we have to determine the charge on that particular metal. For example, ClO3 3. So dito pwede nyo gawin yung tinatawag natin na reverse. So when you say reverse, you are getting the charges of each element. So yung 3, which is the subscript for the ClO3, it will go back to your cobalt. So your cobalt here is cobalt 3 plus. And since this is just 1, then the ClO3 here is ClO3 minus. So from this information, you can deduce the name of the compound. This will become cobalt 3. Why cobalt 3? Because the charge is 3 plus. And the ClO3 is called the chlorate ion. Okay? So COClO3 3 is named as cobalt 3 chlorate. So according to our slide, we can predict the formula for an ionic compound based on the formula of a similar compound. So dito, the prerequisite is the groupings in the periodic table. For example, what is the formula of cesium nitrite given that sodium nitrite is NaNO2? So recall that cesium and sodium, they are both in group 1 or the alkali metals. So they will have the same ionic charge. For example, sodium, it becomes Na plus, then cesium is Cs plus. And then you have your NO2. So NO2 here, NO2 minus is your nitrite. So what will be the name? For cesium nitride, it will become CsNO2. So the formula for cesium nitride is CsNO2. So that ends the discussion for ionic compounds, but it will not stop there because we still have your molecular compound, binary molecular compound. So for binary molecular compound, again you have binary meaning 2 elements, and both of them are non-metals. So binary molecular compounds are composed of 2 non-metal elements, and we will call this your molecule. A molecule is the simplest representative particle of a binary molecular compound. And usually the IUPAC will also set the rules. So for there should be a proper order. So IUPAC has set the following order for writing the elements in a binary molecular compound. So you will always start with the priority is carbon, next is phosphorus, nitrogen, hydrogen, sulfur, iodine, bromine, chlorine, oxygen, and fluorine. So that is the order, the proper order for uh, writing the chemical formula of your compound. So how do we name binary molecular compounds? So when say binary, again, you have two elements. Molecular, these are both non-metal. So the first element in the compound is named first as is. So as is. But the second element will have a suffix of IDE or the I. So if you could remember, we have your bromide, chloride, iodide, etc. And in naming binary molecular compounds, we will use here Greek prefixes. So what is this Greek prefixes? So the Greek prefixes here um, corresponds to the number of atoms of each element. For example, 1 is mono, 2 is di, 3 is tri, 4 tetra, 5 penta, hexa for 6, hepta for 7, octa for 8, and then nona for 9, and then lastly, deca for 10. So you should be familiar with these 10 prefixes for your molecular or the binary molecular compound. And there's a note here. The prefix mono is not used in the naming of the first element. So you don't use the mono for the first element. You can use the mono for the second. Also, the prefix nona is commonly used. Kasi when say nona, 9. The IUPAC prefers the Greek prefix inea. So, pero kasi mas nakasanayan natin is the nona. It's also the same. Also okay. So, for example, what is the name of the molecular compound with chemical formula P4S3? And the other one is P4S7. So, the strategy here is to determine the two elements. So, one is phosphorus, and the other one is sulfur. And we know that sulfur is the second element. We will change this to IDE, so it becomes sulfide. So identify first the elements. Then look at the chemical formulas. You have 4 in the phosphorus, so you need a prefix for 4, and that is tetra. And then for 3, you have tri. So the name for P4S3 is tetraphosphorus trisulfide. So how about this another example? The number of phosphorus is just the same, but you have different number of sulfur. So if you have trisulfide, you have 3s. But since you have 7 here, this will become heptasulfide. So the name is tetraphosphorus heptasulfide. So we are also correct. So we also have exemptions to this rule. So there is one exemption to the use of the Greek prefixes when naming binary molecular compounds. So if there is only one atom in the first element, the Greek prefix mono is not used. So the Greek the Greek prefix mono is always used for the second element. For example, CO. So we know C is your carbon, and O here is oxygen. And since they are bonded together, we will convert oxygen to ide, so oxide. And since you have just a single oxygen, then we will use mono. So if we will add mono plus oxide, medyo ano siya, ah, pangit siyang, hindi naman pangit, um, monoxide. So why not just make it monoxide? So kaya ang pangalan nito is carbon monoxide. Okay? Last one is called the XeF6, called the xenon hexafluoride. So hexa siya kasi anim. As you can see here, it's fluoride because of the F. And then the first element is xenon. So I mentioned nung mga nakaraan na lecture that xenon as well as other non-metal na the noble gases natin will not form compounds except for it was observed in xenon and krypton that they can form compounds. For example, xenon with fluorine is your xenon hexafluoride. Okay? So that is how we name your molecular compounds. And say when say molecular compounds, these are composed of non-metal elements. Binary, meaning you have just two elements. What if we specify the element in the molecular compound? So we will now call this your binary acid. So a binary acid is an aqueous solution of a compound containing hydrogen and another non-metal. So again, ano ba ibig sabihin natin ng aqueous? It means it contains water or it is usually or typically dissolved in a water. So a binary acid is an aqueous solution of a compound containing hydrogen and a non-metal. And the usual start of your formula for an acid, it always begins with H. For example, HCl. And then there's a descriptor here, AQ, meaning this is aqueous. It means your HCl is dissolved in water. So HCl aqueous. So binary acids are named how? By using the prefix hydro. So hydro is attached to the name before the element stem. What is the element stem? For example, chlorine, chlorine, fluorine, etc. And you add the suffix "ic". For example, HF aqueous is called hydrofluoric acid and HI is called the hydroiodic acid. So if you will go back to this HCl, this is your hydrochloric acid. Okay? So these are the names of your binary acids: hydrofluoric, hydrochloric, hydrobromic, and hydroiodic acid. Last will be a discussion on the ternary oxy acid. So, from the name itself, a ternary oxyacid is an aqueous solution of a compound containing hydrogen, an oxygen, and another nonmetal. So, your oxyacids are all made up of non-metals. But there are um, criteria here. So, one is hydrogen and the other one is oxygen. And yun nga, from the name itself, oxy, we have oxygen, and acid, you have the presence of your H. So ternary oxyacids are aqueous solutions of a compound containing a hydrogen and an ion. So the oxy ion here is an oxygen with another nonmetal element. So if you remember, our ions, polyatomic ions, they usually end in 8 and I. So if we will convert this to oxyacids, then there is a change in the name. If the acid is derived from the oxygen ion ending in 8, then the suffix is changed to "ic". So for example, this is HNO3 aqueous. So how do we name this substance? So this comes from NO3, and we know NO3 is your nitrate ion. So you remove the ion and the 8, you replace this with ic acid. So HNO3, upon reaction with H plus actually, it becomes nitric acid. Okay? But if the oxygen ion ends in "ite", then the suffix will be changed to "ous". For example, your HNO2 aqueous is called nitrous acid. Why? Because it comes from NO2 minus, so which is called your nitrite. So you remove the ite ion and you replace it with ous acid. So HNO2 is called your nitrous acid. So below is an example of a ternary oxyacid and a ternary compound naming. So we'll focus more on the acids to your left. So originally, so let's start here. This is your chlorate. So chlorate is ClO3 minus. So we call this as your chlorate. Remove the 8, we replace it with ic acid. So it became HClO3 chloric acid. This one is called your ClO2 minus, called the chlorite. So chlorite, remove the ite, rem replace it with ous acid, so it becomes chlorous acid. If your oxygen is just 1, so it becomes hypochlorite. So hypochlorite siya, ClO minus is hypochlorite. So if you will make this an acid, so you will add the H and the H plus. So magiging HClO siya. The name is hypochlorous acid. Okay. There are also instances that you can actually add another oxygen to your 8 chlorate, for example. So if you add another oxygen from ClO3, it becomes ClO4. So this ClO4 is called ClO4 minus, is called the perchlorate ion. So again, the convention is you remove the 8, you replace it with ic acid. So if your ClO4 minus reacts with H plus, this becomes HClO4 and the name of the acid is perchloric acid. Okay, since we have here another part of the table, let's also discuss the ternary compound. So in ternary compound, you have three elements bonded together: sodium, chlorine, and oxygen. So starting again with this one, so we know that ClO3 is chlorate, then you have sodium, sodium chlorate. This one is NaClO2. ClO2 minus here is the chloride, and then you add the sodium, so it becomes sodium chloride. For NaClO, this is sodium hypochlorite. And then ClO4, ClO4 minus is called your perchlorate. Then you have, uh, if you have Na in the formula, so it becomes sodium perchlorate. Okay, so we're able to discuss the acids, the binary acids, and the ternary oxy acids. So as a summary, so most inorganic compounds do not contain carbon. Let's remember that. Okay. Binary ionic compounds are composed of a metal and a non-metal. Again, ionic, you have a non-metal and a metal. And since binary, you have one metal and one non-metal. On the other hand, you have a ternary ionic compound. This is composed of a metal, a non-metal, and not not necessarily oxygen, but another non-metal. So you need here a metal, at least one metal, and at least one non-metal. But the total number of different elements here will be three. You have three different elements bonded together. On the other hand, binary molecular compounds are composed of two non-metal elements. So binary meaning again two, then you have non-metal elements bonded together. Acids are composed of hydrogen, so H, and a non-metal atom or possibly a hydrogen with an oxy an ion. So cations are named the element plus the word ion. For example, Mg2 plus magnesium ion. So cations with more than one possible charge have their charge indicated with Roman numerals in parentheses. So we use in, for example, copper plus, this is copper 1 ion. So you enclose the charge in parentheses and you convert the number into Roman numeral. Then, ionic compounds are named using the cation first and then followed by the anion. For the anion, you change the suffix to "-ide". The simplest representative unit for an ionic compound is called a formula unit. And the on the other hand naman, for a molecular compound, the simplest representative unit is called a molecule. So a molecule is composed of non-metal elements. Okay? When naming molecular compounds, there is an ordering. So the elements are written in the order of carbon first, followed by phosphorus, nitrogen, hydrogen, sulfur, iodine, bromine, chlorine, oxygen, and then fluorine. So the name of the first element is the same. You just adopt the name of the first element, but you change the ending of the second element with IDE. And we also use the different Greek prefixes to indicate the number of each atom in the formula. So you should be familiar with the prefixes mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So depending on the number of atoms. So again, acid is an aqueous solution containing a hydrogen and a nonmetal or hydrogen with with an oxy an ion. So a binary acid is named as such because you have a nonmetal atom that is bonded with hydrogen. And we use the convention, we use the prefix hydro at the first, and then we add the suffix or the ending "-e". For ternary oxyacid, so when say ternary oxyacid, you have three or more elements. And usually, we know that the oxyanions or the polyatomic anions will usually end in "-ate" or "-ite". So for those ending in "-ate" suffix of the oxyanion, we will convert that to "-e". And for "-ite" suffixes, we will convert that to "-o". So, example natin kanina is uh, chloric acid and the other one is chlorous acid. Okay? So with that, thank you very much for listening and God bless.